So welcome to week 5 for Mathematical Methods for Quantitative Finance. So the first 4 weeks we did a review of calculus, and now we're going to shift focus to linear algebra. And this week's menu is going to be vectors. So a vector is just, you can think of it as a point in a plane. So it's just a pair of numbers, x, y, and then it also can be extended, so you could think of it as a point in 3 dimensions, in which case it would be x, y, z. That would be a vector of length 3. A point in the plane x, y would be a vector of length 2. And so we'll start off just by coming up or going over the basic addition rules and a few other things for vectors. Then in the second section, I'll go through vector length. So unfortunately, one of the things you lose when you start to have points in 2 dimensions is you can no longer say, x is less than y. And so we need another way to compare magnitudes. So we use the length of the vector to do that. And then I'll go into just a little discussion about a plane. So a plane is basically just like a line, but in 3 dimensions. So it ends up having length and width. And then that's going to lead us into systems of linear equations. And so in 2 dimensions, you can think of a system of linear equations as just 2 lines, and what you're interested in finding is the point where they intersect. In 3 dimensions, now we have to think of planes. So 2 planes would intersect in a line, and then a 3rd plane would intersect that line in a point, and that will be the solution to our system of linear equations. And then we're going to start talking about how we can solve systems of linear equations, and that's going to bring us to bullet point 4, elimination. And following from elimination, we're going to end up being able to view the problem we're trying to solve as a matrix. So a matrix is just going to be a collection of vectors. And then we'll look at specifically solving the problem AX equals B. So A is a matrix, X is a vector, and X is the unknown. And then B is another vector. And I want to find the vector x that satisfies this equation. One way to do that is to use an inverse matrix. So that's what we'll talk about in section 7. And essentially, if A were just a number, x were a number, and B were a number, then solving AX equals B would just involve dividing both sides by A. And so inverse of a matrix, I think of that as just A inverse times A times x will equal x, and then whatever's left on the right-hand side would be the answer, A inverse B. And it turns out that in solving this, a nicer way of doing that involves factoring the matrix, and this is going to lead us into next week's lectures. So there are a lot of useful factorizations of matrices that will make seemingly difficult problems a lot easier to solve. And then I'm going to finish up by talking about something called the R environment for statistical computing. And that's just a software program that allows you to manipulate matrices and vectors. We start dealing with this many numbers, it's no longer practical to try and do the calculations by hand on a piece of paper. So it's really useful to have a little bit of experience, at least, with a computer algebra system that can do that for you.